Hello everyone, welcome back to my channel Maths with Math Tips. Today in this video we are solving the WBSET 2020 question booklet series X, and this is the part 5 video of WBSET 2020. The remaining the last videos, the previous videos link, I will share the link in the description and also in the I tab. So those who are new, those who are not watching the videos, so you can go and check the videos for WBSET 2020 solution. So before going to solution, I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. So let's start from question number 56. Now the Fourier transform of fx equal to exponential minus of mod x is. Now the Fourier transform is given by the formula of Fourier transform of any function is given by, this is the script f which denotes the Fourier transform of a function fx is equal to fk is equal to 1 by root twice pi integration minus infinity to infinity fx into e to the power I kx dx. So this is equal to, this is the formula of Fourier transform. So this is equal to, here the function fx equal to e to the power minus of mod x, and now we break the function e to the power minus mod x from minus infinity to 0 and 0 to infinity. So minus infinity to 0 mod x gives the value minus x, and 0 to infinity mod x gives the value only x. So break this function. So this is equal to minus infinity to infinity 1 plus e to the power 1 plus ik into x dx plus 1 by root twice by integration 0 to infinity e to the power minus of 1 minus ik into x dx this. So if we integrate simply these two functions, then we get e to the power 1 plus ikx by ik integration minus infinity to 0, and here minus of integration e to the power minus of 1 minus ik into x by 1 minus ik. Now if we put the upper limit to this function, then this gives only simply e to the power function gives 0, and simply this gives 1 by 1 plus ik, and if we put minus infinity to with x minus infinity, then we get the value 0. Similarly, if we put the value 0 here, the lower limit, this gives minus of this, and here is a minus, so it gives simply 1 by 1 minus ik into 1 by root twice pi. So this is equal to 1 by root twice pi 1 plus 1 by 1 plus ik plus 1 by 1 minus ik. So this is gives 1 by root twice pi integration 2 by 1 plus k square. So this is equal to root over of 2 by pi into 1 by 1 plus k square. So this is the correct answer for the question. That is the Fourier transform of the function fx equal to e to the power minus mod x is given by root over of 2 by pi into 1 by k square plus 1. Option D is the correct answer. So go to the next question, question number 57. Question number 57 says that let L of yt denotes the Laplace transform of yt, and given that this 0 to t yx yt minus x dx equal to 16 sin 40, then Laplace of yt is given by. The question, this question is based on convolution theorem of Laplace transform. The convolution theorem says that suppose ft and gt be two piecewise continuous functions on 0 infinity and both exponential order b. Further, suppose that L of yt, this is the Laplace transform of a function ft equal to fs, and L of gt equal to gx, then L inverse fs gs equal to L inverse L of f compose g into t. So this is equal to f compose g into t. This is equal to integration 0 to t f of t minus v g v into dv. That means f compose gt equal to integration 0 to t f of t minus b into gv dv is called the convolution integral. So here in this question we use this concept. So here it is given that this is yx, also this is y of t minus x. Therefore comparison from this convolution theorem, here both the function fx and gx are yt. So this is equal to, this implies integration 0 to t yt into yt minus x dx equal to this. Now taking Laplace transform both sides, so Laplace of integration 0 to t yt into yt minus x dx equal to Laplace of 16 sin 40. So using convolution theorem, this function gives simply yt into yt. So Laplace of yt into yt, this is equal to Laplace of 16 sin 40, and this is equal to Laplace of sin 16 Laplace of sin 40. So this is equal to the Laplace transform of sin 40, which is given by 4 by p square plus 4 square, and this gives the simply square of the function. So this implies L of yt equal to plus minus 8 by root under p square plus 4 square is the correct answer for this question. Therefore in this question for question number 57, option A plus minus 8 by root under p square plus 4 square is the correct answer. So go to the next question, question number 58. Question number 58 says that the rate of convergence of the iteration process. This is the question from numerical analysis. The iteration scheme is given by xn plus 1 equal to 1 by 8 into xn into 6 plus 3 a by xn square minus xn square by a, given that xn tends to root under a. So this is given. Now we solve the question by this. Let epsilon k be the error term in kth stage and xk plus 1 equal to root under of a plus epsilon k plus 1, since this is xn plus 1 converges to root a. So this is given. Now let us write root under of a plus epsilon k plus 1 equal to 1 by 8. Now put the value of x k plus 1 to the iteration scheme, this xn plus 1 equal to this. So if we take here x k plus 1, then 1 by 8 into root under a plus epsilon k, this is equal to 6 plus we put simply the value of x k plus 1 or x n plus 1. You can take any of prefix suffix, there is no problem. So 1 by 8 into this, and this is simple calculation. So here we take a common from here, root a common from here, and this a cancel. This is gives 1 by 8 into root under a plus epsilon k into 6 plus 1 by epsilon k by a minus 2 power minus 1 by a into root under a plus epsilon k whole square. So this is equal to 1 by 8 root a plus epsilon k into 6 plus 3, 6 plus this gives 3 minus 6 epsilon k by root a plus 9 epsilon k square minus 12 epsilon k cube by a root a, that is a to the power 3 by 2. We take this expansion by using this series 1 plus x to the power minus 2 equal to this. We take up to this in third power term, and remaining we are not take the remaining terms. This is equal to 1 by a into a plus 2 root a epsilon k. This is the square root of square, simply square is given. So this is nearly equal to 1 by 8 into root a plus epsilon k, 6 plus 3 minus 6 epsilon k by root a, and this gives simply calculation, and this is nearly equal to 1 by 8 root a plus epsilon k, 8 into 8 plus 8 epsilon k by root a plus 8 epsilon k square by a minus 12 by a root a epsilon k cube. So this is nearly equal to root a plus epsilon k, and 8 taken common from this bracket and cancel 8. So this gives 1 minus epsilon k by root a plus epsilon k square by a minus 3 by 2 root 2 into a into root a into epsilon k cube. So this is equal to root over of a plus epsilon k, and this is minus epsilon k by root a plus epsilon k square by root a plus epsilon k cube by a minus 3 by 2a epsilon k cube minus 3 by 2a into root a into epsilon k to the power 4. So this gives root a cancel. This is the left hand side of this, starting from x k plus 1, that is root a plus epsilon k plus 1. Therefore root a plus epsilon k plus 1, this is equal to the terms on the right side, root a minus 1 by 2a epsilon k cube plus order of epsilon k to the power 4. Therefore we can write epsilon k plus 1 equal to minus 1 by 2a epsilon k cube plus order of epsilon k to the power 4. So here from this it is clear that the convergence rate of convergence of the iteration scheme is 3. So it is third order convergence. So here option B is correct. The rate of convergence is 3. Now go to the next question, question number 59. On evaluating integration minus 1 integration 1 to 3 integration double integration 1 to 3 x cube by y dx dy. Now from the limit of the integration, it is clear that the two integrations are independent. Therefore we can write these two integrations as a product. So we can write this, and then integration 1 to 3 1 by y dy. Now we apply Simpson one-third rule to both these two integrals. Now Simpson one-third rule says that integration a to b fx dx equal to h by 3 into y0 plus yn plus 4 into y1 plus y3 plus y5 and so on, that is odd terms, and plus 2 into y2 plus y4 plus so on, even term. Now we first apply Simpson one-third rule to this integral and then this integral, and product the value of the integration. So first y equal to fx equal to x cube. Suppose let us take h equal to 1, then x0 equal to 1, x1 equal to 2 and x2 equal to 3. Now this is equal to integration 1 to 3 x cube dx equal to 1 by 3 into y0 plus y2, that is the last term, and here we have only a odd term, therefore 4 into odd term, that is y1. Therefore which gives the value y0 means y at x0, y1 means y at x1 and y2 means y at x2. So this gives the value of 1 cube, 3 cube and 2 cube. So 4 into 2 cube, so this gives 1 by 3 into 1 plus 27 plus 32, this is 60 by 3. Now we apply the Simpson one-third rule to this integration. So this is of the form 1 by x dx, and here y equal to fx equal to 1 by x, take h equal to 1 similarly. So x0 equal to 1, x1 equal to 2 and x2 equal to 3. Here the general formula is xn equal to x0 plus nh. So this gives 1 by integration 1 to 3, 1 by h dx equal to 1 by 3 into y0 plus y2 plus 4 into 1 odd term. So this gives since y equal to 1 by x, therefore y at x0 equal to y0 equal to 1 by x0, y1 equal to 1 by x1 and y2 equal to 1 by x2. This gives the value 1 by 3 into 20 upon 6. Therefore the value of the integration is simply the product of these two integrals. So this is equal to 60 by 3 into 1 by 3 into 20 by 3, and 60 tens are, and so 20 into tens are 200 by 9. So 200 by 9 is the correct answer for this problem. So option D is correct here. Now go to the next question. Question number 60. Question number 60 is from integral equation, and here is the constant limit. So this integral is from freedom integral equation. Now the integral equation says that we write it in the form yx equal to lambda into integration 0 to pi sin x cos t plus cos x sin t into yt dt. So this is the freedom integral equation with separable kernel, because we separate the kernel and we can write the kernel as a product of f1 and g1 as a function of x and t respectively. So we can take here fx equal to sin x, f2 equal to cos x, g1 t equal to cos t and g2 t equal to sin t. So we find the value of alpha ij equal to 1 by 2 pi integration gti fjt into dt. Ij is equal to 1 and 2, ij takes the value 1 and 2. So alpha 1 equal to integration 0 to 2 pi g1 t f1 t dt, and the value of g1 t is cos t and value of f1 t is equal to sin t. So sin t cos t dt, and this gives integration 0 to 2 pi half into sin dt, which gives the value of the integration 0. Alpha 1 2 equal to g1 t f2 t dt. This is equal to g1 t means here g1 t means cos t and f2 t means cos t. So this gives the value cos square t, and which is simply integration gives the value pi. Similarly alpha 21 equal to pi and alpha 22 equal to 0 using these two integration. This is easy calculation, so I can skip this calculation. So d lambda equal to, now d lambda equal to 1 minus lambda alpha 11 minus lambda alpha 12 minus lambda alpha 21 1 minus lambda alpha 22. Now here to get the value of lambda we must have lambda is non-zero. So this is equal to 1, we put the value of alpha 11 alpha 22 and the value of alpha. So this gives 1 minus lambda alpha lambda pi minus lambda by n1, and the eigenvalues are given by d lambda equal to 0. So d lambda equal to 0 imply 1 minus the lambda square pi square equal to 0. So this is equal to lambda square equal to 1 by pi square. So this gives lambda equal to plus minus 1 by pi. Therefore the eigenvalues of the freedom integral equation question number 60 is 1 by pi and 1 minus 1 by pi. This is the correct answer, option number B. Now going to the next question, question number 61, and before going to the question I am requesting you to all please subscribe the channel, like the video, share with your friends. Now question number 61 says that the characteristic number lambda of the corresponding characteristic function phi x of the homogeneous freedom integral equation. This question is also from integral equation where the kernel is given Now we write the Freedom integral equation as in the form integration 0 to x. First we take, since this is t is the variable, t is the, we integrate with respect to t, then from 0 to x the value to where t less than equal to x, the kernel takes the value t into x minus 1, and from x to t, that is where x less equal to t, that is in this interval, the separable kernel takes the value x into t minus 1, lambda into x, lambda x into t minus 1 yt dt. Now apply the boundary condition. To get the boundary condition, we put the value at x equal to 0 and x equal to 1, and we get a value of y0 equal to 0 and y1 equal to 1. We need these two values to solve this equation. Now here we apply the Lemnis rule for differentiation. Now Lemnis rule says that ddx of integration gx to hx f xt dt equal to gx to hx del f del x dt plus f of the second variable is replaced by upper limit and then the differentiation of upper limit, and minus the, in this functions f of xt, the second variable, that is t, is replaced by the lower limit and the derivative of lower limit. So this, apply this rule, we have y dash x equal to integration 0 to x ty t dt plus lambda into x minus 1, since t is replaced by t x here, since upper limit is x, so this is equal to, and the lower limit is, since the lower limit is constant, so the differentiation of lower limit gives the value 0, and plus similarly we apply same thing in this equation, the second part also. So we get here integration 0 to x lambda t yt dt plus integration x to 1 lambda into t minus 1 yt dt. So again we apply Leibniz theorem to here. This is the value of yt. We get y double dash t equal to 0, since there is no function of x, so del x of this gives 0, and this gives then lambda x into yx, since the t is replaced by the upper limit and the differentiation of upper limit, then the lower limit is constant, so this value is 0. Here also this is, there is no x, so the partial derivative with respect to x gives 0, since upper limit is constant, so this also gives the 0, and since here the lower limit only variable, so this gives lambda into x minus 1 into yx. So this gives y double dash x minus lambda yx, since here we only have the lambda yx, so this is equal to 0, and we have already have the condition these two. So we now apply case 1, when lambda equal to 0, then we have trivial solution. When lambda greater than 0, then we also have trivial solution, but we don't need this trivial solution, because this two trivial solution does not give eigenvalue. Therefore we interested only for non-trivial solution. Now for lambda less than 0, lambda equal to minus k square, we gives the non-trivial solution. So we get yx equal to a cos kx plus b sin kx, while lambda equal to minus of k square, and y0 equal to, apply y0 equal to 0, we get a equal to 0, and then we get yx equal to b sin kx. Now apply y1 equal to 0, we have b sin k equal to 0, but if we take b equal to 0, then this solution also give trivial solution, and we are not interested in the trivial solution, we are interested only non-trivial solution. So this gives sin k equal to 0, so sin k equal to 0 gives sin n pi, n equal to 1 to n dollar, and this is equal to k equal to n pi. So lambda equal to minus of k square equal to minus of n square k square. Therefore the eigen function is yn equal to, since we have this function only yx equal to b sin kx, this gives the eigen function. So ynx equal to bn sin n by x. If we take bn equal to 1, since this is constant, so we get for n equal to 1 lambda equal to minus pi square, and y1x equal to sin pi x, and for n equal to 2 lambda equal to, we get minus 4 pi square, and y2x equal to sin of 4 pi x. Now we check the options for the correct answer. Now for lambda equal to minus pi square, pi x equal to minus sin pi x, this is correct, and for lambda equal to 2 pi square, these are not correct from our calculation. So here only A option is correct. Go to the next question, question number 62. The circular equation of helix. This is a straightforward question. The helix looks like this. This is an image of the helix, and the general solution for the circular helix is given by x equal to a cos t, y equal to a sin t, and z equal to bt. This is the general equation of circular helix, which is in the form this. Go to the next question, question number 63. The number of positive integers between 1 to 1000 which are divisible neither by 2 nor by 5. So we first calculate the number which are divisible by 2 and 5, then subtract those numbers from 1000, then we get our answer. So let's start the solution. There are total 1000 integers from 1 to 1000. 5000 of these are even, that is they are divisible by 2, and there are 200 integers which are divisible by 5. Now LCM of 2 and 5 gives 10. Therefore the multiple of 10 between 1 to 1000 is divisible by both 2 and 5. Therefore there are total 100 integers which are divisible by 10 between 1 to 1000, which are already counted when we counted the divisibility of 2 and 5. Therefore the number of integers between 1 to 1000 which are neither divisible by 2 nor by 5 are given by 1000 minus 200. These are divisible by the number of integers divisible by 2. These are the integers which divisible by 5, and this is divisible by 2 and 5 both, which is add with this number, which gives the value 400 is the correct answer for this problem. Therefore option D is correct here. Go to question number 64. 64 is a statement based question of graph theory. The complete graph of n vertices contains two edge disjoint spanning tree if and only here the answer is n greater equal to 4. This is strictly a result based question. Answer is n greater equal to 4. Go to the question number 65, and this is the last question of 2020 WBSET from mathematics part. The remaining question from 66 to 100 is from statistics part. So this is the last question, and this question is from calculus of variation. So which of the following curve can give an extremum of the functional j yx equal to integration 0 to pi y dash square plus 12xy. Therefore here the function is given by f of x y y dash equal to y dash square plus 12xy. Now we apply here simply Cauchy-Lagrange equation, Euler-Lagrange equation, sorry. So which is del f del y minus ddx of del f del y dash equal to 0, and the value of f x y y dash is given by this. So simply apply, we get 6x minus y double dash equal to 0. So we get y double dash equal to 6x. Now integrating with respect to x, we have y x equal to 6x square by 2 plus c1. c1 is the integrating constant, and integrating again we get y equal to x cube plus c1x plus c2. Now apply the condition given here, y0 equal to 0 and y1 equal to 1. We have y0 equal to 0, then c2 equal to 0. Therefore y equal to x cube plus c1x. Apply y1 equal to 1, we get c1 equal to 0. Therefore y equal to x cube is our required extremal. Here option C is correct. This is the last question for this video. So how was the video? If the video is helpful, please give a like to this video, share with your friends, and subscribe the channel. Thank you friends. See you again in the next video. Thank you.